Hello, this is Mr. Moore again, and in this video, we'll show how to find the equation for a tangent to a curve using the methods we talked about in class and what you'll have to do for your homework problems. And we'll also show how you can do this with the Epiphany AI tutoring system to get you some feedback along the way and catch some of those detailed algebra mistakes that might pop up while you're doing it. So I've already got an assignment set up here, tangent line example, and we're going to click over here to enter a new problem. And let's see, I'm going to use, here's our problem. I have not shared my screen yet. I have recorded this 2 other times and not shared my screen. We all make mistakes, just saying. I am now sharing the wrong screen. Let's try this one more time. Sharing screen number 1. There we go. Okay, so now you can actually see, and I'm going to go back here. I'm going to go back to assignments. We were here. I opened up this example, the tangent line assignment that I had created, adding a new problem. This problem, I'm entering the name as find the slope of the tangent line to the curve y equals x minus x cubed at the point 1 comma 0. All right, so how do we do this? Well, I want to find the limit of the slope as the 2 points get really, really close to each other, close to the point 1 comma 0. It is the limit as x approaches this one value, the one value of the point, of the slope between these 2 points. That's the difference function, f of x minus f of 1 divided by x minus 1. So we're going to enter that as the problem we're going to solve first. I'm going to use m for the slope, and that's equal to, now there's 3 different ways you can enter problems here in Epiphany. One is you can enter them using text and shortcuts. And for some things like exponents and fractions, it's pretty obvious what to do. For other things like limits, it's actually kind of hard. So we're not going to try and do that with limits. You also can enter problems through handwriting recognition. That's more intended for tablets and cell phones, things like that. Here, we're going to use a GUI. So we've got a keyboard over here, just like on Desmos. We're going to open up functions, calculus, and here's a limit. And we want the limit as x approaches 1 at that point 1 comma 0 of, well, we've got the function, and I'm going to put this in parentheses, x minus x cubed, caret gives me the exponent like you'd expect, minus 1 minus 1 cubed. I'm separating this with parentheses because I find it useful to make sure I'm clear about what I'm doing. I'm going to put that all over. Oh, oops, wait a minute. I wanted the whole thing over in the top of the fraction. I'm going to hit backspace to get rid of that division symbol. And I can use shift left arrow to select everything I want in the numerator. Now hit the slash symbol and I get the whole thing in the numerator over x minus 1. Okay, so we got that. That's going to be our problem. It looks good to go. And enter will start our work. Now, you're not going to enter any of that because mostly you're going to just hit this button to copy this entire problem and paste if you use Epiphany. If you're doing this on paper, you're going to rewrite it. I recommend writing out the limit, making clear that you're using the limit until you actually evaluate the limit. Let's continue with the first step. Here in this first piece, we can get rid of the parentheses because there's nothing around it, no multiple in front of it, no negative in front of it, no exponent. This other side has a negative in front of it, so I'm going to simplify the insides first. Oh, wait, this is just 0. This is easy. Okay, I can either hit enter or click on next step to check this. And I'm going to take little steps just to make sure I'm not making mistakes along the way. Let's copy and paste this. And this time, yeah, when I'm factoring an expression, I like to have the highest order exponent term first. So I'm going to factor a -1 out of this and make this x cubed plus x here. So let's try that. Oh, oops, I made a mistake there. When I factored out a -1, I had to factor it out of x2. I should get minus x. Sometimes if you make a mistake, you might get some questions pop up over here. You can answer them if you want, or sometimes you might just want to skip over them. In this case, I'm going to say, oh, I made a sign error. And we'll continue. Okay, I'm going to copy and paste again. And let's try this. Next step. There we go. All right, now we're going to factor this a bit. Let's factor out an x. Negative x times x squared minus 1. And when I hit enter here to this step, you're going to see an issue come up. This is actually an error inside our system. When there's a variable right before parentheses with implicit multiplication, sometimes that looks like a function to us. We can't tell whether that's like y of a function or f of a function or multiplication. So we recommend putting a multiplication symbol there whenever there's a variable before a parenthesis, if that's what you want to do. And when I do it this way, it's going to work just fine. We're working on that. Continuing from there, we have x squared minus 1. That factors into x minus 1 times x plus 1. And now we can just plug in 1. M equals negative 1 times 1 minus 1, 1 plus 1 over 1 minus 1. And you probably see what's going to happen here. This is not going to work because I have 0 over 0 here. It's confused. I'm just going to escape all that and clear the messages. I have to simplify it before I take the limit. So let's cancel the x. Let's cancel the x minus 1s, get rid of that. And down here, get rid of that. And we can just hit backspace again. It'll get rid of that fraction. Next step. And we're good. Now I can just plug in negative 1. I get m equals negative 1 times 1 plus 1. And m equals negative 2. You know, one of the nice things about using this as a way to help do your problem is if you make a little mistake along the way, it's caught right away. You know, so many times in calculus, it's the little mistakes in algebra, in sign errors, in exponents that get in the way of understanding what's going on. By catching those mistakes along the way, it makes it easy to really focus on the core calculus and understand what's going on. So we've done that. The next step in this problem is we have the slope. The slope was negative 2. Let's plug into the equation, which is down here. Okay, we want to find the equation for the tangent line with the slope in part A. That was a slope of negative 2 through the point 1 comma 0. And I'm going to type the generic form of the equation, y minus y. I'll use underscore to make y sub 1 equals m x minus x sub 1. You'll notice that I forgot to put a multiplication symbol here, but that's okay because I'm going to enter this as a free text entry problem. It's not going to check it. We're just going to be able to enter whatever we want and answer it so that all of the different problems are in the system. Let's begin like that, and we're just going to plug in. The point is 1 comma 0, so this is y minus 0 equals negative 2 x minus 1. Enter that, and we're done. So this is a way that we can use either both finding the instantaneous rate of change through a limit and using the point slope form of a line to find the tangent to the curve, whether it's done on paper or here in the system. I'm going to show you another assignment here. This is the assignment for homework. This will be in the system if you want to use it to do your homework. And let's go ahead and click on next problem. Actually, no, I'm going to click on print assignment. And these are backwards, unfortunately. Sorry about that. You'll notice that there's some extra space for problems 1 and 2. I listed these as just free response with some place to write in your answers rather than having you type it in. I thought that might be easier for you. And when you want to, you can either print PDF or print it out. And in this case, you want to print it out and write your answers for these other problems in, whichever works best for you. So this is an overview of how you can solve problems involving the tangent to a curve by finding the slope of the instantaneous rate of change with the limit of the difference function, and then plugging that into the point slope function.